observations made to estimate the radius of the moon have shown that the semi-vertical angle of the tangential cone drawn with the vertex at the observer O and touching the rim of the moon as 1/4 of a degree. Use this information to determine the radius of the moon, given that the center of the moon is at a distance of 384,000 kilometers from the observer, and for small angles sin theta is same as the angle theta measured in radians. So once again, observations made to estimate the radius of the moon have shown that the semi-vertical angle of the tangential cone drawn with the vertex at the observer O and touching the rim of the moon is 1/4 of a degree. Use this information to determine the radius of the moon, given that the center of the moon is at a distance of 384,000 kilometers from the observer O, and for small angles sin theta is same as the angle theta measured in radians. Now, let this be the moon and the observer is here, and it is given that the center of the moon is at a distance of 384,000 kilometers. And now a tangential cone is constructed so that the vertex of the cone is at the observer. So this is the moon. The center of the moon is taken as a C, and let us take this radius of the moon to be R. Now, a tangential cone is made so that the vertex of the cone is at the observer O. So therefore, this is the cone. Suppose if I take this as A and this is B, OAB is the tangential cone, and the semi-vertical angle, that means this, if this is theta and this is given as 1/4 of a degree. Now this angle OAC is 90 degrees because OA is the tangent, CA is the radius, the tangent is perpendicular to the radius, therefore OAC is 90 degrees. In the similar way, OBC is also 90 degrees, and angle OAC is equal to angle OBC is equal to 90 degrees, and CA is equal to CB is equal to a radius of the moon. Now this is the position of the moon, this is the center of the moon, and the observer is here, and the distance from the observer to the center is given here, and a tangential cone is made so that the vertex is at the observer, therefore the tangential cone is OAB. Angle OAC, OA is tangent, AC is a radius, like that OB is the tangent and CB is the radius. So OAC is equal to OBC is equal to 90 degrees, and CA is equal to CB is equal to R. Now, this theta is equal to 1 by 4 into pi by 180 radians. Now from here, triangle OAC or from the right angle triangle OAC, sin theta is equal to CA by OC, and sin theta is given to be equal to theta because when compared to the circumference of the moon, the angle is very small, and when in smaller position sin theta is given as theta, and this is CA is R and OC is 384,000. And now this theta is 1 by 4 into pi by 180 is equal to R by 384,000. So 1 0 gets cancelled here. Now therefore R is equal to this is pi, we can write it as 22 by 7 into this is 1 by 72, and this comes on this side into 384,000. So the value of pi is written as 22 by 7, and after cancelling the 0, 4 into 18 is 72, and this comes on that side. So therefore it is 384,000. So here 2 11s and 2 goes 36 times here and 2 goes 18 times here. Once again 2 goes so therefore this is equal to 11 into 9600 by 63. And further simplification or by actual division, it will be 1676.19 kilometers. So therefore, this is the position of the observer's eye, and this is moon. The radius of the moon is 6. The distance from the observer to the center of the moon is given here, and OAB is the tangential cone, and the semi-vertical angle of the tangential cone is 1 by 4 degree. Now OAC and OBC are right angle triangles. CA is equal to CB is equal to R, and theta is equal to 1 by 4 into pi by 180 radians. And from this right angle triangle OAC, sin theta is opposite side is CA and hypotenuse is OC. And in smaller values of theta, sin theta is given as theta, therefore theta is pi by 4 into 180 radians is equal to 6 by this one. So now R is equal to, this is 22 by 7, 4 into 18 becomes 72, and this comes on this side. And further simplification, the answer will be 1676.19 kilometers. That means 1676.19 kilometers. So if a person of normal sight can read a point at such a distance that the letters subtend an angle of 5 minutes at his eye. What is the height of the letters that he can read at 756 meters? Let this be the height of the letters above his eye level. So this is the eye level and this is the height. Let this be taken as some h. And this is given as 5 minutes. So OP and OQ both are equal. So OP is equal to OQ is equal to R, and this is the height of the letters PQ. And when the man is at a distance of 756, so therefore this is 756, we have to find the height. So if we consider this to be an arc and the height is h, the length of the arc is h, and the radius is 756, and this is 5 minutes and theta radians is equal to h by r, and 5 minutes is 5 by 60 degrees, and in radians it is 5 by 60 into pi by 180. So therefore 5 by 60 into pi by 180 is equal to h by r is 756. Therefore h is equal to 5 by 60, 22 by 7, 1 by 180 into 756. 5 goes 36 times. So this is on multiplication 16632 by 15120. It will be nearly equal to 1.1 meters. The wheel of a railway carriage is 4 feet in diameter and makes 6 revolutions per second. How fast is the train going? The wheel of a railway carriage is 4 feet in diameter and makes 6 revolutions in a second. How fast is the train going? Diameter of the wheel is given as 4 feet. Therefore, radius r is equal to 2 feet. So the radius of the wheel is 2 feet, and for one revolution it completes a distance of 2 pi r feet is equal to 4 pi feet. So the diameter of the wheel is given as 4 feet, and hence the radius of the wheel is 2 feet. And for one revolution, that means circular path, it travels a distance of 2 pi r feet, and r is given as 2, therefore it is 4 pi feet. A number of revolutions per second is 6. Therefore, distance traveled is equal to 6 into 4 pi. Is 24 pi feet. So therefore, the diameter of the wheel of the carriage is given as 4 feet, thereby the radius is 2 feet. If it makes one complete revolution, it travels a distance of 2 pi r. So therefore, for one revolution, it is 4 pi feet. And the number of revolutions per second are 6. So for 6 revolutions, it travels a distance of 6 into 4 pi, 24 pi feet, and hence it will be the speed per second. Find the angle between the hour hand and minute hand of a clock in circular measure at 4:30. Find the angle between the hour hand and minutes hand of a clock in circular measure when the time is 4:30. Now in 12 hours, our hand makes 360 degrees. Because the hour hand makes a complete revolution on the circumference, thereby it makes 360 degrees in 12 hours. Therefore, per hour, it makes 30 degrees. And in 60 minutes, that is 1 hour, the minute hand makes 360 degrees. Therefore, per minute, minute hand makes 6 degrees. Now, at 4:30, that is at 4:30, the minute's hand will be at 6 and the hour hand will be in between 4 and 5. That means it will be 4 into 1/2, 9/2. So therefore, in 12 hours, the hour hand makes one complete revolution and thereby it makes 360 degrees. Hence, per hour, it makes 30 degrees. And in 60 minutes, the minute hand makes 360 degrees, and hence per minute, it is, it makes 6 degrees. Now, at 4:30, this will be in between 4 and 5. That means at 4 1 by 2. That means it travels 9 by 2 hours. So therefore, the minutes hand, the hour hand travels a distance of 9 by 2 hours by that time, and the minutes hand makes an angle, and here it is at 6. Now if this is the clock round and this is 12 and this will be 3 and this will be 6, and here it is 4 hours and here it is 5. So originally when the hour hand starts here and goes for one complete revolution, it makes 360 degrees. So it makes an angle of 360 degrees in one revolution. So in 12 hours, our hand makes 360 degrees. Hence, it makes 30 degrees per hour. And at 4:30 it will be here. That means it will be in between 4 and 5. That means it travels, it makes 9 by 2 hours. At 4:30, our hand makes 9 by 2 hours, and per hour it makes 30 degrees. Therefore, the angle made by it, angle made by our hand is equal to 9 by 2 into 30 is equal to 135 degrees. So therefore, if this is A and this is P and this is O, this angle is 135 degrees. So in 12 hours, the hour hand makes one complete revolution, and to make one complete revolution, it will complete 360 degrees. So hence it makes 30 degrees per hour. And at 4:30 means it will be at 9 by, it will make 9 by 2 hours, because at 4:30 it will be in between 4 and 5. Therefore, the hour hand makes 9 by 2 hours. So in 9 by 2 hours, angle made by it is 9 by 2 into 30, thereby it is 135. Now, minutes hand makes 360 degrees in 60 minutes. So per minute it makes 6 degrees at half past 4. Minute hand makes 30 seconds. Therefore, angle made by minute hand is 30 into 60, 180. Even otherwise also you can see when it starts here and comes here, the angle will be naturally 180. So this is 180. So therefore the angle between the two, angle between hands is equal to 180 minus 35 equal to 45 degrees. So in 12 hours our hand makes 360 degrees, hence it makes 30 degrees per hour. At half past 4 our hand makes 9 by 2 hours. So angle made by the hour is 9 by 2 into 30 degrees, 135 degrees. In the same way, the minute hand makes 360 degrees in 60 minutes. So per minute it is 60 degrees. At half past 4, it travels 30 seconds, and after 30 seconds, it makes 180 degrees. Even otherwise also this is getting coincided with this, therefore the angle is 180. And angle made by the minute hand is 180, our hand is 135. Angle between them is 45 degrees.